Repeated Bernoulli trials. Suppose an experiment consists of a number of repeated identical trials. For example, an experiment might consist of tossing a fair coin 6 times. Each toss of the coin is called a trial, and these trials are both identical and independent. The outcome of any individual toss has no bearing, which means no effect, on any toss that may follow. Repeated identical trials are called Bernoulli trials, after Jacques Bernoulli, 1654 to 1705, one of a large family of Swiss mathematicians, if they satisfy the conditions outlined in the following definition. So, these are the conditions that follow Bernoulli trials. So, a number of repeated trials are called Bernoulli trials if they are independent, they are identical, and each trial has only 2 possible outcomes, which may be termed success and failure. So they must be independent, identical, and have only 2 possible outcomes, success and failure. For example, repeatedly tossing a coin and being interested in the number of heads are Bernoulli trials. We would call getting a head in a single trial a success, and then getting a tail is a failure. So tossing a coin is probably the most common example. However, other examples of Bernoulli trials are: was a newborn baby a girl? So the success is she's a girl. The failure is it's a boy. Did a voter vote for a particular candidate? So the success is yes, they did. The failure is no, they didn't. Did a shopper buy a particular product? The success is yes, they bought it. The failure is no, they didn't buy it. In each case, there is a clear idea of success, yes, and failure, no. And the trials may be repeated, with each trial having no bearing or no effect on any other. Many trials appear to have more than 2 possible outcomes, but by an appropriate grouping of the possible outcomes, we may consider that there are only 2, which we will then call success and failure. For example, suppose a die is thrown repeatedly, and we are interested in the number of times we get 5 or 6. Well, you might say to yourself, well, there's 6 possible outcomes, so this cannot be a Bernoulli trial. However, if we call success 5 or 6 and failure 1, 2, 3 or 4, then it does become a Bernoulli trial. For a single Bernoulli trial, it is usual to let P equal the probability of success and Q equal the probability of failure. These letters are important, because we must either get success or failure. The success or the failure should add up to 1. So the probability of success plus the probability of failure equals 1. So P plus Q is equal to 1. Thus, Q is equal to 1 minus P. There are a number of types of questions on Bernoulli trials. So type 1, first success or first failure. Suppose we have a number of identical Bernoulli trials, each with a probability of success P and a probability of failure Q. What is the probability that the first success occurs on the 4th trial? If the first success, S, is in the 4th trial, then the first 3 trials must all end in failure, F. Because the trials are independent, we can use the multiplication rule. So the probability of the first success in the 4th trial is the probability that the first we have a fail, and second we fail, and third we fail, and fourth we have success. Remember, and means multiply. So it's going to be failure times failure times failure times success, which is Q times Q times Q times P, which is Q cubed P. In general, the probability of getting the first success in the nth trial is Q to the power of n minus 1 P. Likewise, the probability of the first failure occurring in the nth trial is p to the power of n minus 1 q. Repeated Bernoulli trials, first success and first failure. Suppose a single Bernoulli trial has a probability of success p and a probability of failure q, then the probability of the first success occurring in the nth trial is q to the power of n minus 1 times p, and the probability of the first failure occurring in the nth trial is p to the power of n minus 1 times q. So for example, up here we looked for the first success in the fourth trial, and the probability of the first success occurring in the nth trial is q to the power of n minus 1 times p. So if it was the fourth trial we're interested in, 4 minus 1 is 3. So we should end up with q cubed times p, which is what we got here, q cubed times p. So if it had been the fifth trial instead of the fourth trial, it would have been 5 minus 1, which is 4. So it would have been q to the power of 4 times p. If it had been the sixth trial, it would be 6 minus 1, which is 5. So it would be q to the power of 5 times p, and so on. So if you would rather not use p and q, and instead you want to use s and f, this is the way you can look at the formula. So suppose a single Bernoulli trial has probability of success s and probability of fail f, then the probability of the first success occurring in the nth trial is f to the power of n minus 1 times s, so f standing for fail, s standing for success, and the probability of the first failure occurring in the nth trial is s to the power of n minus 1 times f. This is not in the formula book, you must learn it off by heart. So let's have an example. For a single trial p, the probability of success is 0.4. Part 1. Find q, the probability of failure in a single trial. Well, we're going to use our formula that the probability of failure is equal to 1 minus the probability of success. So q is equal to 1 minus p. So it's going to be 1 minus 0.4, which is 0.6. So the probability of failure is 0.6. Part 2. If the trials are repeated, find the probability that the first success occurs in the fourth trial. If the first success is in the fourth trial, then the first 3 trials must all result in failure. So the probability that the first success is in the fourth trial is going to be fail and fail and fail and success. So q times q times q times p, which is q to the power of 3 times p, which is 0.6 to the power of 3 times 0.4, which is 0.0864. Part 3. If the trials are repeated, find the probability that the first failure occurs in the third trial. If the first failure occurs in the third trial, then the first 2 trials must result in success. So the probability of the first failure in the third trial is going to be success and failure, which is p times q, which is p squared times q, which is 0.4 squared times 0.6, which is 0.096.